Okay, so the world of AI research has absolutely exploded. It's like a giant maze, with thousands of new paths and discoveries popping up every single year. It's gotten to the point where it's literally impossible for any one person to keep track of it all. So that begs the question, what if AI could draw its own map? Well, today we're diving into a new system that does exactly that. It's creating a compass for this incredibly chaotic but exciting world of scientific discovery.
So here's our game plan. First, we'll get a handle on the sheer scale of what we're calling the AI paper tsunami. Then, we'll introduce the new research compass that's been built to navigate it. After that, we'll take a peek under the hood to see how it works, check out the amazing maps it can generate, and finally, we'll talk about what it really means when a technology gets smart enough to start understanding itself.
All right, so to really get why this new tool is such a massive deal, we first have to appreciate the size of the mountain that researchers are trying to climb every single day. Get this, over 10,000 new research papers are published in AI and robotics every year. That works out to almost 30 papers a day. It's not just a stream of new info, it's a full-blown tidal wave. And honestly, even the top experts in the field are struggling just to keep their heads above water. And this right here, this is the fundamental problem. On one hand, you can have a brilliant human expert spend an entire year writing a deep, accurate summary of a field, but it's basically obsolete the moment it gets published. On the other hand, you can use an automated tool that's super fast, but it just skims the surface and misses all the important details. We've always had to choose between slow and deep or fast and shallow. Well, until now. This is where a totally new approach comes into play. A team of researchers from UC San Diego and NVIDIA basically asked, can we build a better compass? And their answer is a system they call Real Deep Research, or RDR for short. It's designed specifically to chart a course through this dense information jungle. And what RDR lets you do is, frankly, pretty incredible. Just imagine being able to type in a niche topic and instantly get a high-quality summary. Or what if you could see which ideas are getting hot and which are cooling down? It can even spot hidden connections between different fields and give you a custom-made reading list of the most important papers. That's the kind of power we're talking about here. Okay, so how in the world does this thing actually work? How does RDR take this chaotic mess of thousands of documents and turn it into a clean, structured map of knowledge? It's a really brilliant four-step process. First, it just hoovers up all the data, thousands of papers. Then, and this is the real magic trick, it uses an AI to read every single paper, but it reads them through the lens of a human expert. After that, it organizes everything, sort of like plotting each paper on a giant map, where similar ideas are neighbors. And finally, it analyzes the clusters on that map to spot the big themes and trends. So, what do we mean by these perspectives? You know, the best way to think about them is like an expert's checklist. When RDR analyzes a new AI model, it's not just skimming the summary. It's actively looking for specific things. What kind of data went in? What's the core design? What did it produce? This forces the AI to think less like a machine and more like a seasoned researcher who knows exactly what to look for. And this is what makes the system so incredibly powerful. It adapts. When it switches to looking at robotics, the whole checklist changes. Suddenly, it's not asking about software architecture, it's asking about the physical world. You know, what sensors does the robot have? What kind of body is it in? This flexibility means you could, in theory, point RDR at almost any scientific field. So, what actually happens when you unleash this powerful engine on an entire field like robotics? Well, you start to see some really fascinating patterns emerge. And here we go. This is what it finds. The RDR analysis shows a huge surge of interest in things like remote-controlled robots and robots with really fine motor skills. But at the same time, some of the older methods seem to be slowing down a bit. This isn't just a list of topics, it's like a weather map for science, showing researchers where the next big storm of discovery is likely to hit. Now, this is where it becomes a real game changer for an individual researcher. Let's say you're really interested in that rising trend, dexterous manipulation. You just ask RDR, and boom, it instantly spits out the definitive reading list. These are the foundational papers you have to know. It just cuts right through all the noise and points you straight to the good stuff. But you might be wondering, how good is it really? Well, the researchers actually had a bake-off. They pitted RDR against some other big-name AI models. They had human experts rate the quality of the summaries each AI made, and the results, well, they speak for themselves. RDR came out on top, and by a pretty wide margin. It just proves that having a powerful AI isn't enough. You need that expert-guided structure to get real insight. So this brings us to the really big picture, because this tool isn't just about organizing AI research. It's a potential blueprint for speeding up discovery in any field, really. You know, the creators said it best themselves. They hope this work can shed light for researchers far beyond AI. And just think about the possibilities for a second. What if we could apply this same expert checklist idea to the flood of research in cancer biology, or climate science, or materials engineering? We could potentially accelerate breakthroughs everywhere. Ultimately, what we're looking at here is something pretty profound. It's an AI that can create a clear, coherent map of its own complicated and chaotic world. It's a tool for finally taming information overload, for finding that one critical signal in an ocean of noise. And it leaves us with a really tantalizing question. Now that AI can map itself, what other maze should we ask it to map for us next?